This is lesson 5 in your workbook on page 529, and it's called the slope formula. So before we get into what the slope formula is and the equation of the slope formula, I want to recap a few things from the last lesson, which was on the slope of a line. And remember that, so just jot down that the slope of a line segment is equal to rise over run. So the first thing, there's essentially 4 different line segments that I could draw. A line segment going up from left to right, coming down, a horizontal line segment, or a vertical line segment. Draw these 4 line segments on your piece of paper at the top, and above or next to each line segment, either put positive, 0, undefined, or negative. Because what you need to be able to do is just look at these and right away be able to tell me that's a positive slope, that's a 0 slope, that's an undefined slope, that's a negative slope. Okay, so see if you're able to do that. If you did it correctly, this one here, it's like you're going up a mountain. And whenever you go up a mountain, that's a positive slope. This one, you're sliding down the hill, it's a negative slope. If I had a person here walking on the ground, this ground doesn't have any slope, right? So the slope would be 0. And this would be like falling off a cliff, and this slope would be undefined. So just to go through a couple of statements here, it says slope is the measure of, and it's the steepness of a line. Slope is a ratio. And we could always write our slope as a fraction because we know that slope is rise over run, right? So slope is a ratio of the vertical change. So vertical is your rise, and over the horizontal change, which is your run. So slope is rise over run. C says a line segment which rises from left to right. This line segment has a positive slope. D, a line segment which falls from left to right, is going down the mountain, has a negative slope. A horizontal line segment has 0 slope, and a vertical line segment, so an up-down line, has an undefined slope. And then the slope of all line segments on a line are equal. So what this last one is just essentially saying, let me just erase that here. What this is saying is if I gave you a line segment, and that's your line segment, and I said, okay, well, what's the slope from here to here? So let's say you counted your rise and your run, and you got the slope was 2/5. And then I said, okay, well, what would your line segment, what would the slope be from here to here? If the slope on this line is 2/5, it doesn't matter which 2 points I pick, the slope will still be 2/5, okay? Let's do one example from here. So what I'm going to do is I'm going to show you how we would have done this in the last lesson, which would be slope is equal to rise over run. And then I'm going to give you the slope formula. So if I said, okay, calculate the slope of line segment AB for me, you would say, okay, the slope, and then tell me what line segment you're dealing with. So slope of line segment AB, slope is rise over run. So rise of 3 and a run 1, 2, 3, 6. So the slope of line segment AB is 3/6. We always, you guys, need to reduce the fraction. So whatever this fraction is, check to see if it would reduce. So the slope of AB, 3/6 reduces to 1/2. So we're really rising 1, running 2, right? So from here, we rise 1, run 2, and you get back on your line. Rise 1, run 2, you get back on your line. Rise 1, run 2, back on your line. So that is the slope formula from yesterday. Now, we very rarely are going to be able to do rise over run. most of the questions are going to want you to use what's called the slope formula. So the first thing that I need you to know is that the word slope, we actually can denote with a variable, and that variable is m. So if you are asked to calculate m in an equation, they're actually asking you to calculate slope. And the equation for slope is as follows. So I'm going to write m is equal to, because m is slope, y2 minus y1 over x2 minus x1. That is what we call your slope formula. So what is this y2, y1, x2, x1? What that means is on your given line segment, you need 2 points. It does not matter which 2 points you choose. Okay, you pick any 2 points on your line segment. So if I was to pick these 2 points here, the coordinate at point A, that x value is 1 and the y value is 8. And the coordinate at point B, the x value is 7 and the y value is 11. So what you need to do in order to apply your slope formula is you pick any 2 points on your line segment. Then what you're going to do is you're going to call the first point x1, y1. If your first point's x1, y1, what do you guys think your second point is? Second point would be x2, y2. Okay, once you have your 2 points picked, and again, it does not matter which 2 points, label them x1, y1, x2, y2, and then you simply plug it into this formula. So slope is equal to y2 minus y1. So go up to your graph. There's my y2, and there's my y1. So 11 minus 8 over x2 minus x1. So now I'm going to go back to my graph. Here's x2, which is 7, minus x1, which is 1. So 7 minus 1. Slope is equal to 8 minus 11 is 3, 7 minus 1 is 6, and then you reduce. 3 over 6 is the same thing as 1 over 2. I'm just going to check, is that what I had? Yep, slope of line segment AB is 1 over 2. So then now I'm going to write this, and I'm going to say the slope of AB is equal to 1 over 2. Some of you might be saying, okay, we prefer doing rise over run, right? Like, why can't we just do the rise and the run? The reason is going to be, if you flip your page, a lot of times they're just going to give you a question like class example 1. And they're going to say, find the slope of a line which passes through this point and this point. So which passes through these 2 coordinates. You don't have any graph paper, and they're going to say, just calculate the slope of the line. So you say, oh, okay, I can't do that rise over run business. So you're going to have to say, I have to use that slope formula, right? So the slope formula, slope of, and I'm going to say what line segment this is. This will be GH, is equal to, the equation of the slope formula is y2 minus y1 over x2 minus x1. All you need to calculate slope is 2 points. So they've given me 2 points. I'm going to call this point x1, y1, and I'm going to call this point x2, y2. Once you have your 2 points, you simply just need to plug it into the formula, and then you're going to get your answer. So the slope of line segment GH is equal to y2 minus y1. So there's y2. Then I must put a minus, and then y1. So that's 8 over x2. So here's x2, 7. You have to put a minus, and then x1. x1, you guys, is negative 3. Right? So you just plug it in exactly as you see this. y2 minus y1 over x2 minus x1. Negative 2 minus 8 is negative 10. 2 negatives down here make a positive. So this would be 7 plus 3, which is positive 10. Slope of GH is equal to, Negative 10 divided by 10 is negative 1. Now, sometimes students will say to me, well, isn't slope rise over run? Like negative 1 is a fall of 1, but what would my run be? So yes, slope is equal to rise over run. So turn this into a fraction. You could put any number over 1. So then my slope is a fall of 1 and a run of 1 to the right. But in your book, the solution would just be slope is negative 1. Okay, and then you could turn it into a fraction if I ever asked you to graph this. Okay, let's look at class example 2. And this will actually be the last class example, and then I'm just going to get you to practice. Eleanor, Bonnie, and Carl are calculating the slope of the line segment with these endpoints here. So slope of line EF. So without even looking at their work, we're going to actually calculate what the slope of EF is. Y2 minus Y1 over x2 minus x1. So I need 2 points. They've given me 2 points. I'm going to call these 2 points x1, y1 and x2, y2. Okay, let's plug this in. So y2 minus y1, 6 minus 8, all over x2 minus x1, negative 10 minus 15. 6 over 8 is negative 2 over negative 10 minus 15 is negative 25. I feel like I made a mistake somewhere. 6 minus 8. Okay, sorry, no mistake is made. 2 negatives make a positive. So the slope, the correct slope of EF is equal to 2 over 25. So a rise of 2 and a run of 25. So that's the answer. We're not going to bother figuring out what each person did wrong. You just have to know how to apply this formula to get slope. Okay, that is it for this lesson. There's only 3 questions for homework. Basically, we need you to understand and be able to plug in and use a slope formula. So we want you to do questions 1, 2, and 3. We're not going to be doing that. Question number 1, 2, and 3. Remember what I said for this? You should be able to just look at this and write plus, minus, negative, or undefined, right? So going up a mountain is positive, sliding down is negative. This is falling off a cliff, which is undefined, and this would be like a flat ground, which is 0. So figure out all of the, like what you would write for each one of these. So again, either positive, negative, 0, or undefined. And then from here, you're just going to be given, so there's 6 examples that you're going to do. Every point you get, x1, y1, x2, y2, write your slope formula. Slope of, I should say, ST is equal to y2 minus y1 over x2 minus x1. And from there, you just plug it in, right? So y2, negative 27, minus y1, exactly as I see it, would be negative 41, over x2, negative 20, minus x1, 36. If you typed it on your calculator, negative 27 minus negative 41, or you could type in negative 27 plus 41, the answer that you should get is 14. Negative 20 minus 36 is negative 56. And then you always have to reduce, right? So on your calculator, 14 divided by negative 56. Math 1 fraction, that's going to be negative 1/4. So my slope of line segment ST is negative 1/4. So I fall 4 and run to the right, sorry, fall 1, run to the right 4. And then you're doing same thing again, right? Every single point, label x1, y1, x2, y2, and use your slope formula.